Hello, I am Aditi Kumar and welcome to another session related to machine learning models, especially categorization of machine learning models. So, how it is basically divided into multiple types based on its working and I can say the application point of view. So, let's discuss deeper into that. So, the concept today I am going to cover, so basically understanding the discriminative and generative models. So, before directly going to generative AI or generative models, or maybe I can say modeling within the generative AI, I need to provide some basic ideas how the entire modeling actually is categorized and how the generative models actually coming into the picture, and what is the difference between the discriminative and generative model, and how the generative models are different from the discriminative model with respect to its working, with respect to its behavior and approach. So, let us dive into that to understand more and more. So, if I am talking about discriminative model and generative model, so machine learning models can be classified into two types, I can say. One is a discriminative and another is generative, right. So, if I will elaborate these two concepts to categorization of the model, a discriminative model basically makes a prediction on unseen data based on the conditional probability and can be used either classification or the regression problem statement. So, basically the classification and the regression statements or maybe problem statements are supervised machine learning, where we are having some label data, target data as a reference. So, at that time we are using the conditional probability to predict something or to get a probability ki what is the probability that a particular thing will happen. So, basically the fundamental concept behind the discriminative model is like this. On the other hand, a generative model focused on the distribution of the data set and return a probability of the given example. So, it is basically based on the similarity. It will be basically presenting the unseen data as a distribution, and maybe I can say as a distribution, or using basically some likelihood technique to see how it is similar to whatever the existing, or maybe whatever actually we are generating, how much it is similar to the previous one or previous event or previous data, right. Let's elaborate more in the next slides, I can say. If I am talking about approach perspective, how it is working, starting from discriminative model. In case of a discriminative model, to find the probability, they directly assume some functional form. For example, so here I can say there is a function, it's basically y equal to f of x. So we are basically presenting directly or setting that particular data set or data observations into a particular function, so that directly we can use the probabilitical technique or maybe that conditional probability to predict the output based on the input value. But in the generative model, it's quite different. It is basically we need to basically predict the conditional probability, but the approach is quite different. So here generative models basically using to find that conditional probability with the probability of y of given x, they estimate the prior probability p of y first. And the likelihood probability p is basically p x given y, how likelihood that particular observation is, with the help of some training data, and then use the Bayes theorem to calculate the posterior probability. This is basically the concept here to calculate, or here basically at the end for these two cases our end goal is to get the probability of y given x, but in the second case we are basically calculating the likelihood probability to see how much it is similar, whatever actually we are going to predict, how much it is similar to whatever the reference we are using to generate the data. This is basically the concept of a generative model, how basically this generative model is different from discriminative model. If I am talking about core idea, behind this. Core idea is discriminative model draw a boundaries in the data space, while generative models try to model how data is placed throughout the space. A generative model explains how the data was generated, while the discriminative model focuses on the predicting of the level of the output. These are basically the two concepts here. I can say this is the core idea behind these two models. Always generative model actually focuses on I can say how the data is generated, and it is based on I can say how the data is placed throughout the space, throughout the vector space, I can say, because each and every time actually, if I am talking about mathematically and we are computation we are doing using different libraries, but behind this actually some linear algebra is basically getting used to represent the data into the vector space. So in that case the space is signify this particular concept. Definitely we will go later actually in depth into that, but this is basically the space, meaning that it's basically the linear algebra vector space. If I am talking about a mathematical intuition behind these two type of model, so in the descriptive machine learning model, or basically to train a model which is done by learning parameters that maximize the conditional probability. On the other hand, a generative model learns the parameter by maximizing the joint probability. This is a one difference. That is basically the difference between discriminative machine learning and generative machine learning model mathematical intuition point of view. Always basically discriminative model is using the joint probability for maximizing the joint probability. Here actually in the generative model we are using basically the optimization technique to maximize the joint probability. And if I am talking about application perspective, always the descriptive models recognize the existing data. That is, descriptive modeling identifying the tags and sort data then can be used to classify the data, while generative model is producing something. Always it is producing something, but here we are basically tagging the existing data and we are predicting basically something, or sorting, maybe I can say putting some complicated rules behind the model to classify something, but generative model itself is producing something. So since the models are different approaches to the machine learning, the both is suited to specific task. That is, the generative model is useful for unsupervised learning problem. In contrast, the discriminative models are useful for the supervised learning task. This is basically the difference from application perspective. Example point of view, if I am talking about a discriminative model, there are some logistic regression, basically support vector machine, so and here neural network. So these are the basically SVMs, neural networks, your logistic regression. These are the supervised machine learning techniques. These are, I can say, discriminative models. And here generative model point of view, autoregressive model, Bayesian networks, GAN. These are the, maybe I can say, a type of basically unsupervised learning problems or unsupervised machine learning models. So if you will summarize everything, so I can say your discriminative, your generative. So here in the discriminative, we are always using the conditional probability y given x directly, but here we are basically using the Bayes theorem through likelihood function, likelihood probability, I can say, but it is applicable for supervised problems, supervised ML. It is mostly suitable for unsupervised machine learning model. And third, I can say So here we are using maximization technique, and here also maximization technique, optimization technique I can say. Here we are maximizing conditional probability of I can say y of x. Here basically we are maximizing the joint probability xy. These are basically the main difference behind discriminative and generative models. Then the later stage maybe we will dig dive into, because discriminative models actually there are basically all models and which are basically going to predict, and for example different deep learning techniques or maybe different classification model, regression model, these are basically the discriminative techniques, and definitely we will have different playlist of that. But generative model actually, before going to the generative AI, dig dive into the modeling behind the generative AI. So I thought I will cover this particular generative model concept, where actually the generative model is coming into the picture. Then maybe based on that we will dig dive into the modeling technique of generative AI. So before directly jumping into the modeling the generative AI, so I thought I will first cover where the generative AI models actually coming into the picture, how it is basically categorized from machine learning models, so that it will be pretty easy for us to understand the later videos wherever we will go for modeling behind generative AI, or how the maybe I can say that related to language, or maybe natural language, or related to or maybe image, how the basically generative models actually different models, the foundational model, or maybe language LLM models, how the different models are working, what is the significance behind any model, or what is the core of this any model, will definitely understand. So this is basically some basic videos I can say to differentiate the different, maybe I can say some top level categorization of the models with the entire machine learning models. So thank you very much for watching this particular video. Please do subscribe my channel so that I can provide some more useful content based on your expectation. And also please share this particular video so that actually others can get benefited out of that. So once again, thank you very much for watching this video.